Hey friends, this is Gus with another video of Your Space TV. The European Space Agency plans to launch a comet-chasing mission in 2029. This mission so far is going to be called the Comet Interceptor. Whoa, the Interceptor! That sounds pretty cool. If it were to be a NASA mission, they'd probably change it to a much larger acronym.
You have to be so strong. All right, I'll do it.
Right? Don't they always do that? This mission was approved on June 19th, 2019 at the ESA Program Committee meeting, and it will be a collaboration between Europe and Japan. This mission is a F mission, a fast class mission. They are made with the shortest timeline, taking only about 8 years for them to go ahead and make it and launch it. This Comet mission will consist of one large spacecraft, kind of like a mothership, and two small probes, one built by Japan and the other one by ESA. It will also launch in space together with a European exoplanet hunter aerial. What's so special about this mission is that we have been doing flybys of comets for decades, but all the comets that we have been seeing are what's called short period comets. Comets that already orbit our sun. It's like Halley's Comet, which is its closest approach to Earth is every 75 years or so. Halley's Comet normally comes in half the distance between the Earth and the sun. It's during this approach that the surface of the comet starts to sublimate, throwing gas and dust into space. These particles coming from the solar winds interacts with the gas, forming what we see as the comet tail. I remember the first time I saw a comet. It was Halley's Comet back in 1986, I believe. At the same time, the movie Space Camp came out. Wow. Remember Space Camp? That was a great movie. They should redo that movie. While I was sitting there drinking my chocolate shake with my grandmother, probably watching Space Camp for the third time, the Giotto spacecraft was flying with Halley's Comet, bringing us the first close-up images of a comet's nucleus. As Giotto approached the comet, it was seasoned with about 12,000 dust impacts, including one that almost ended the mission. It passed so fast that it only had a few brief moments to take these close-up pictures. Europe continued its study of comets with the Rosetta mission, which launched in 2004 and took 10 years to reach 67P, taking a super up-close image from many angles. It even tried to send a lunar probe to the surface. Now, NASA had some comet missions also. NASA's Stardust mission took samples of dust particles from Comet V82, returning them back to Earth in 2006 for study. NASA also did a comet impact mission in July of 2005. But like I said before, all these comets were short period comets. The long period comets are pretty different. These come from the outer solar system and an area filled with icy objects, which has never been seen before. The astronomers have found comets that take more than 200 years to go around the sun. Some even thousands or even hundreds of thousands of years to complete one orbit. These objects are the DNA of our solar system. They are all in the Oort cloud until some event kicks them into a trajectory that brings them into the inner solar system. This could happen many ways. A large passing star near them, a brown dwarf, can also disrupt them, or they can just hit each other, making it leave the cloud. These objects can reach speeds up to 1.2 million miles per hour, or 482 kilometers per second. But they can also come into our solar system and then head back out into space, never to be seen again, such as the famous Oumuamua, which scientists believe that comet was its first orbit around our sun, and its materials was from the birth of our solar system 4.6 billion years ago. So studying such an object will help us not only know more about comets, but also about how the solar system formed and evolved over time. Launching in 2028, it will be sent to the Earth-Sun L2 Lagrange point. There it will wait and pounce on the target. When the right comet or interstellar object is detected, ESA will send the command to have the spacecraft make an intercept trajectory. A few weeks before that, the spacecraft will break apart into its separate elements. They will have cameras, a dust field and plasma sensors, of course an infrared camera, and some ultraviolet sensors. If by any chance no interstellar objects come within 3 or 5 years, they do have a backup plan of going to a short period comet. But the real success would be for it to find another Oumuamua, if I'm even pronouncing that right. I've heard it said a couple of different ways. Now remember, an interceptor is just a quick look, a couple of close-up pictures, and off it goes. Ideally, you would really want to orbit the comet, but that takes a completely different class of mission, especially at the speeds that they normally have. I love the fact that we're launching a spacecraft all the way to L2, just to sit there and chill. We just don't have the means to spot the object first and then prepare a rocket for launch. I always say to my girls that being prepared always has the best results. Well, my friends, I could go on and on and on talking about comets, interstellar objects, and such things like that, but man, I can smell some tacos cooking up in the kitchen, and if I don't stop now, I'm going to be drooling all over myself. I'm not sure if you're going to want that. Man, it smells good. So I hope you got some value and knowledge from this video. Engage that like button, and thank you if you did, and I'll see you on the next video. It's your space. Man, taco time.